Welcome to the Deep Dive. Today we're getting into multi-threading and concurrency in programming. Uh, Basically, how software seems to do lots of things at once.
Yeah, without, falling over.
Exactly. And you sent in some really focused questions about this.
Right. So our goal here is to unpack the key ideas, maybe clear up some of the term.
And give you a solid handle on why multi-threading is a thing and how it actually works under the hood.
Sounds good. Should we maybe start with the basics, like multi-threading versus multiprocessing? Are they the same?
Good place to start. What's the core difference there? Lay it out for us.
Okay, so think of multi-threading. It's like having several tabs open in one browser window. They're all part of that one browser process.
Okay, sharing the browser stuff.
Right, sharing resources. Now, multiprocessing is more like having completely separate browser windows open. Each window is its own independent process, its own memory, everything.
Okay. So why threads then? If processes are separate and maybe safer, why have multiple threads inside just one process? What's the upside?
Well, the big advantages are usually responsiveness and potentially speed,
How so?
while responsiveness. Say one thread is stuck waiting for, I don't know, network data. Other threads in the same program can keep running.
So the program doesn't just freeze up while it waits. The user interface still works.
Exactly. And performance-wise, if you've got a computer with multiple CPU cores, different threads can literally run at the exact same time on different cores. Parallel execution.
Which could make things faster.
Potentially, yeah. But that resource sharing you mentioned.
Right, the thing that makes threads efficient.
Yeah.
Does that cause trouble?
Oh, absolutely. It's a double-edged sword. Sharing memory is great for communication between threads, but it's also where the problems creep in.
Like what kind of problems?
The classic one is a race condition. This happens when the program's outcome depends on the unpredictable timing of threads accessing shared data.
Okay. Give me an analogy.
Imagine two people trying to update the same number on a shared whiteboard at the exact same moment. Maybe they both read the starting number, add something, and write it back.
But the order they write it back matters.
Totally. You could end up with the wrong final number because one person's update overwrites the others, or they interfere somehow. It depends purely on who gets there fractionally sooner.
Right, a jumbled mess, like you said. A digital tug of war. So how do programmers stop that chaos?
That's where thread synchronization comes into play. It's basically a set of rules and tools to coordinate these threads.
To control who gets access to the shared stuff and when?
Precisely. To prevent those race conditions and keep the data consistent, you use things like locks or mutexes, mutual exclusion locks.
Mutexes, okay, how do they work?
Think of a mutex like a key to a shared resource, say, that whiteboard number. Only the thread holding the key, the lock, can write on it. Any other thread that wants access has to wait until the first thread is done and releases the key.
One at a time.
Yep, exclusive access. Then there are things like semaphores. They're a bit more flexible. They can allow, say, up to 5 threads to access a resource pool concurrently, but no more than 5.
Okay, so different tools for slightly different coordination needs and all this juggling. The OS is doing this, switching between threads.
Yes, the operating system is constantly switching between the active threads, giving each a slice of CPU time. That's called context switching.
Is that switching fast? Or does it slow things down?
It's very fast, but not free. There's a small performance cost, an overhead, each time the OS saves the state of the current thread and loads the state of the next one.
Like changing gears mentally. A tiny pause.
A good way to put it. Now, you often hear concurrent and parallel used, sometimes interchangeably.
Yeah, what's the actual difference there? Is there one?
There is, and it's important. Concurrency is about dealing with multiple things seemingly at the same time, managing multiple tasks. Even on a single core CPU, you can have concurrency by rapidly switching between threads. They look like they run together.
Okay, so concurrency is about the structure, the management of tasks.
Right. Parallelism is about actually doing multiple things at the exact same time, executing simultaneously. This requires hardware support, multiple CPU cores.
So you need multiple cores for true parallelism.
Correct. You can have concurrency without parallelism, like that single chef juggling orders, but parallelism is a form of concurrency, like multiple chefs working side by side on different orders.
Got it. Concurrent is managing simultaneous-looking tasks. Parallel is actually executing simultaneous tasks.
Nicely put. And the operating system is the master coordinator, the air traffic controller for all these threads.
Scheduling them, managing the locks and resources.
Yeah, trying to keep everything running smoothly and fairly, making sure those synchronization rules are followed.
Okay, so let's recap. Multi-threading lets programs be more responsive, potentially faster, by using threads that share resources within one process.
But that sharing needs careful management using synchronization tools like locks or mutexes to avoid problems, like race conditions.
And the OS handles a complex job of scheduling these threads and switching between them, distinguishing between just managing concurrent tasks and enabling true parallel execution on multi-core systems.
That's the essence of it. Harnessing concurrency, aiming for parallelism where possible, but always managing the shared state carefully.
It really is pretty amazing how much complexity is hidden away, just making our apps feel smooth and responsive.
It is. So maybe a final thought for you listening. Next time an app seems to be downloading something while you're still scrolling or typing, think about that unseen dance of threads, the locks, the context switches.
All that coordination making it possible.
Yeah.
Definitely something to mull over. Thanks for diving deep into multi-threading with us today.